David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you could turn on the captions and follow along with my words on the bottom of your screen. Today's topic, dependent events. So now we're entering into the territory where one event occurring will affect the probability of the second or a second event occurring. So this is kind of our definition. Occurrence of one event affects the occurrence of a second event. So think about it this way. If I have a bag of marbles, in this case I've got 5 blue and 3 red, if I pull out one marble and put that aside, now the probability changes for what color I get the second time because there's fewer marbles in the bag. So there's a lot of situations where this happens. For example, if I have a deck of cards and I calculate the probability of pulling out a heart twice in a row, the first time it's 1 out of 4. The second time it's not 1 out of 4 anymore because we removed a heart from the deck. So there's fewer hearts in there. So it's going to change that probability. It won't be 1 out of 4 again. So I want to show you how this works mathematically and then we'll do some problems. So let's say, in this case, we're interested in what is the probability that the second pick from the bag of marbles is blue. Not the first pick, but the second pick. So there's 2 routes. We could get blue first and blue second, or we could get not blue first and then blue second. Let's calculate those 2 probabilities. So probability of 2 blues, so I'm just going to write that B comma B, is going to be 5 over 8 times 4 over 7. Do you see why it's that way? The first time, there were 5 blues out of 8 total, but we've pulled that blue out. So now there's only 7 left in the bag, and we reduced the number of blues as well, so there's 4 left. So this would end up being 20 over 56, which we could reduce down. Let's leave it at 56 because I think that's going to help us compare our other one. So now we want probability of not blue and then blue. Remember, we're looking for second pick blue. So we calculated getting 2 blues because that satisfies the condition. Now we're going to calculate not blue first and then blue. So not blue first would be getting, in this case, just red. So that's 3 out of 8. And then now we still have 5 blues in the bag, but we have 1 less because we pulled the red out. So now it's 5 out of 7. And so this becomes 15 over 56. So you can see how the first event affects the probability of the second event. In other words, we pulled a marble out, that's going to affect the probability of what comes next. So that's just to give you an example of how this works. Okay, let's formalize what we just learned in that last example and make another rule that we can use. Okay, so if A and B are dependent events, not independent, but dependent, then the probability of A and B is equal to the probability of A times the probability of B given that A happened. Okay? So you have to specify that probability of the first event having happened. So in our example, that was pulling 2 blues from the bag. We got, the probability was 5 out of 8 for the first blue. Now, given that the first blue happened, what's the probability of getting our second blue? It's going to be 4 out of 7, which is 20 over 56. So that's from the last example. This kind of formalizes that. Once we get into trees, you're going to automatically account for this. That's the nice feature about using probability trees. Okay, let's use this in an example with a probability tree. I have a bag of fruit. I've got a bunch of oranges and a bunch of apples in the bag. Let's count these up. Well, that'll be useful. There's 6 oranges and there's 3 apples. Okay? Now, let's make a tree. This is going to be really helpful. I'm going to do apples here, oranges there. Now, we add probabilities to our trees. So apples, we have 3 out of 9. This is 3 over 9 for apples. And for oranges, we have 1, 2, 3, 4, 5, 6 out of 9. And we're just checking across here, 3 over 9, plus 6 over 9 is 9 over 9, which is 1. So that's what we want to see. Now this is where it gets a little bit more tricky. Now we're drawing from the same bag, okay? So we have the same options. We have apples and oranges, apples and oranges. But now the odds are different because we have our numbers in the bag have changed. So we've drawn one apple out of the bag. So the number on the bottom is going to drop to 8 because there's only 8 left in the bag. And we picked one of the 3 apples before, so now there's only 2 out of 8 left. Okay? So this fraction and this fraction have changed. Now for oranges, we still have the same amount of oranges in the bag, which was 6, but we only have 8 total pieces of fruit. So that's 6 over 8. Now let's take a look at the other option. For apple, we still have 3 apples in the bag because we drew an orange last. So this is going to be 3 over 8. And this one is going to be 5 over 8. So you really want to understand just how these fractions, these probabilities changed based on what happened before. So these events are dependent on the first event. And this is all because now we're choosing from the same bag. Every time we take a piece of fruit out, it changes the odds for drawing one or the other of the remaining fruit. Okay? So you want to make sure you understand how that works. Okay, let's do 3 examples, but keep in mind there's a lot of possible variations on this. Okay, so probability of an apple, then an orange. So apple first, orange second. Pause the video, see if you can do that. Okay, that would be the probability of an apple first, that's 3 over 9, times an orange second, which is 6 over 8, which is 18 over 72. Okay? So that's your probability of apple first, then orange. Now, 2 oranges. Pause the video, see if you can do that one. Okay, let's see how you did. First orange is 6 over 9. Second orange is 5 over 8. So this is going to be 30 over 72. Okay? How about this one? Probability of 1 each. Okay, let's see how you did. So there's 2 ways to get it. Apple first, orange second, or orange first, apple second. So let's do apple first, 3 over 9, times orange second, 6 over 8, which we know from up here, that's 18 over 72. And then we're going to add orange first, 6 over 9, times apple second, which is 3 over 8, which is also 18 over 72, which is, adding them together, it's going to be 36 over 72, which is 1/2, which is 50%. So in this example, you have a 50-50 chance. If you draw twice from the bag, which I erased, you draw twice from the bag, you're going to get 1 each of each fruit. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.